Hello, this is our last lecture in relational model. So we'll talk about division operator. So this can be a little bit confusing, but once you get the semantics of it, it will become easier. So whenever you see the keyword for all or for every, we know that we're going to be using the division operator. So usually this involves two relations. So we have R and S. R, whatever comes first before on the left-hand side of the division operator, will contain A1 through AM and B1 through Bn, and whatever appears on the right-hand side of the division operator will contain B1 through Bn. So we know that R and S will contain at least one common attribute, and then R will contain more. Okay, so here we have R, and then we have ID and course ID. Okay, so takes and then ID and course ID. This will return the list of all the course IDs or courses that this person has taken. Okay, and then this one is going to be course where department name is biology. This will return the list of all the courses in the biology department. So R divided by S will give us students who have taken all the courses in the biology department. Okay. Let's take a look at an example here. So we have R and S. R contains A, B, C, D, E. S contains D and E, so we know that D, E are in common with R and S, right? Okay, so let's take a look at, so we want to find combinations of A, B, C, which is associated with both A1 and B1. So Z, A, Z. Do we have the Z and Z with A1 and B1? Let's see. ZAZ is with A1. Okay, do we see ZAZ with B1? Actually, that's the only ZAZ, so that does not qualify because we are not able to find ZAZ B1. Okay, the next one we have ZAY. Okay, we have that with A1. Let's see if we can find ZAY with B1. So the next one we have ZAY with B1. So ZAY shows up with A1 and B1, right? Which is from S. So we are able to return ZAY as one of the rows. Okay. Let's take a look at the next one. XAY has A1. Do we see XAY with B1? No. Okay, we have XAY with B3, so that's not any of these, so we can't use that. YAY shows up with A1. YAY shows up with B1. So YAY does qualify, so I'm going to put that down as the second row, YAY. The last row has YAX with B1, but we do not see YAX with A1, so we're not able to put that down. Here is another example. We have A, B1, B2, and B3, so these are different combinations of division. On the first one, A divided by B1, we want to find SNO that has P1. Okay, P2. So P2, so we have S1, so we're going to put that down. Another P2 right here with S2, so we're going to put that down as well. Another P2, so S3. Another P2 with S4, so we're going to put S4. So whenever this B1 only has this one single value, it's pretty simple, it's easy. On the next one we have B2 has P2 and P4. Okay, so S1 is associated with P2. We also have to find S1 with P4, right? Let's see. Yes, we do have S1 with P4, so we're going to put S1 down here. Okay, and then let's take a look at P3. So we have, actually P3 doesn't qualify. Okay, we have S2 and then P2. We have S2 and P2. So do we also see S2 with P4? Let's see. S2 P4, no, so that does not work. We have S3 and then P2. Do we also see S3 with P4? No. Okay, we have S4 with P2 and S4 with P4, both. So we are able to put S4 down as one of the answers. Okay. Now the last one is A divided by B3. So we need to find an SNO that is associated with P1, P2, and P4. Okay, so we have S1 and P1. S1 and P2, and then S1 and P4, all three. So S1 does qualify. For S2, we have P1 and P2, but we don't see S2 with P4, so that does not work. P3, we have it with P2, but not P1 or 4, so that does not work. For S4, we have it with P2 and P4, but we don't see S4 with P1, so that also doesn't work. So the only thing that works here is S1. So we want to return those courses that have been taught in all semester or in every semester. So that's the keyword here. We know we're going to be using a division operator. Okay, so we have to think about semantics. Okay, so let's take a look at this first part. Okay, so the first part is going to be from the course taught. This is the course code, okay, the code of the course or course ID. Okay, and then this is the semester that it was taught, and then we have the instructor ID, which is not really relevant. We don't really care about who was teaching it. Okay, we just care about courses that were taught in all semester. Okay, so this first portion returns the course ID and then the semester of all the courses taught. Okay, so it's going to be a combination of all the course IDs and semester. And here, the right-hand side of this division operator will return all the courses or all the semesters that this course was taught. Okay, so just one way to look at it is courses that have been taught, which will be course ID. Okay, that is the first thing you put, and then whatever appears after all or every is semester. So you want to put that semester both in here and here. So as a result, it will return a list of course IDs, okay, where semesters are in common. Here is another example where we find all customers who have an account at all branches or in every branch located in Brooklyn City. So here we have a bunch of different tables. We want to find out which ones are relevant. Okay, so the first one we're looking at depositor and account. Okay. So we're taking a natural join between depositor and account. Okay, and depositor and account, these two, where they have the account number in common. Okay, and we're returning the customer name as well as a branch name because we care about, whoever has an account, whatever customer has an account, and all the branches located in Brooklyn City. Okay, so this will return the name of all the customers and then which, every branch that they have. So if they have multiple accounts in different branches, we'll have the customer name and the branch name. So we might have multiple lines or rows of the same customer if they have multiple accounts. Okay, and then we have the division, and then this one is returning just the branch name. So this is going to return the list of all the branch names where the city is located in Brooklyn. So again, I'm going to be looking at whatever appears before the all, so which will be on the customers, right? So we have customer name here, and then after all shows up branches. So I'm going to put the branch name here and here. So if this customer has a branch in every city, in all the locations, every location in Brooklyn City, their names will be returned as a result. Okay, so we have dealt with fairly, simple relational algebra expressions, and this is kind of the order that we do it. Okay, so we have, we're going to be displaying whatever attributes. So this will just specify, I only want to see these attributes. And then you could, have more than one table. So these are different types of joins. This is a natural join. We also have talked about the Cartesian product. Okay, and then this is the predicate, right? Okay, so we have product. We want to display the product ID, and the name here is going to be Gizmo. And we're taking a natural join between purchase and person. But for the person, we only care about displaying the social security number, whose name is Fred. So we're joining these two tables first, and then taking a natural join between that and product with this predicate only showing PID. And from that, we're taking a natural join between that and person, okay, where the buyer SSN is equal to SSN, and we want to see the name. So it can get pretty complex, so it might be easier for you guys to kind of break it down into subqueries to make it more easier to understand visually. Okay, the last topic we're going to talk about is aggregate functions. Okay, these are very useful, fairly easy to use. Okay, so there are 5 aggregate functions. Okay, so there's the average function, min, max, sum, and count. So these are the 5 functions, and so these are keywords. Okay, and you can also group by a certain attribute. You can group by more than one attribute. So we have a relation called R here with 3 attributes, A, B, and C. We have some values in here, and we want to use an aggregate function. So this is the symbol that you use for aggregate function. Looks like a G, right? Lowercase g. And then out of the 5 functions, we have decided to use sum. So we have these 5 options. We're using sum. Okay, so we put the name of the relation in parentheses like we've always been doing it. And then we have this aggregate function symbol followed by the name of the actual function. We're using sum. And in parentheses, we're going to pick a column or attribute name. In this case, we're picking C. So we're taking a sum of all of the values from the C column. So that will be 7 plus 7, which gives you 14. 14 plus 3 gives you 17. 17 plus 10 is 27. So it will return a single value, 27. And it's not going to say sum C. It's actually just going to say C. If you want to give it a name, you have to rename it. You know how to use rename function. Here's another example. We have account, okay, and we have branch name, account number, and balance as the attributes. Okay, and we, in this example, we are grouping by something. Okay, so here we have branch name on the left-hand side of the G, the aggregate function symbol. So that means we are grouping by branch. Okay, and then on the right-hand side, we have account. We're accessing account relation, and we want to use the sum function, and we want to sum all the balance. So that's going to be the balance of all the balance, right? But we are grouping by branch name, so we want to look at different branches. So the first group that we see here is Perry Ridge. We have 2 rows of that. Okay, so when you take the sum of these 2 values, it's going to return 1300 or Perry Ridge. Okay, and notice how it's going to be returning exactly 2 columns. The first one's going to be balance, branch name, and then the second one's going to be balance. It's not going to say sum balance, it's going to just return balance. So next one is Brighton and another Brighton. So we have 2 rows for Brighton branch name. So we're going to take the sum of these 2 values, which will give you 1500. Okay, and then the last one is Redwood. There's only 1, so it's going to return 700. So this is how you can kind of group by one of the attributes. You could also have multiple using just commas. Okay. So because it just says balance, and we meant to, in reality, it's actually sum of all the balance, right? So you can use this symbol as, this is a keyword. So we just do branch name, aggregate function symbol, sum of balance, as this is a keyword, and now this attribute will have a name, sum-balance. This is a new attribute name, okay, and then we are accessing that from the accounts. Okay, so you cannot really compute transitive closure in relational algebra. That's one limitation of using this. Okay, so here we have names of 2 people and their relationships. So Fred and Mary. So Fred is the father of Mary. Mary and Joe are cousins. Mary and Bill are married, they're spouses. And Nancy and Lou are sisters. Okay, so these are different relationships, but using relational algebra, you cannot, say, okay, Bill is the son-in-law of Fred. We're not able to come to that kind of conclusion. Okay, so that's one limitation of RA. So these are all the operations that we have gone over so far. Okay, so we have used the select symbol, project. We talked about different joins. This join data join could be, less than or equal to, greater than equal to, not equal to. So it's any kind of a Boolean expression that goes here for the join condition. And you're joining R1 and R2, okay, based on this condition. Okay, equal join is, the only difference is that this join condition can only have equal sign. Okay, you cannot have less than or anything like that. Natural join will join R1 and R2, where the common attribute from R1 and R2 are equal to each other. You could also have union, intersection, set difference. Okay? And then we talked about Cartesian product where we're taking every single possible combination of R1 and R2. Okay, so this would not really be useful just by itself. You would have to probably add a predicate like a condition to set something to equal to each other. And then we just talked about division. Okay, whenever you see the keyword all or every, you will use division. And then lastly, we talked about the 5 different ways we can use aggregate functions. There were 5 total: average, min, max, sum, and count. Okay, so that's a brief summary of everything that we have done so far in relational algebra. As you can see here, we will do something similar in SQL starting the next lecture. Okay, so our last exercise, we're using the same database. Number 1, assume the companies may be located in several cities. Find companies located in all cities in which small bank corporation is located. Okay, so the keyword, I hope you noticed that is all, every, so we know that you're going to be using a division operator. And number 2, find the average salary of all employees for each company. So here we're looking at average salary. So, okay, so that's going to be a function, right? Average function. So you can go ahead and pause this video and work on these queries. And once you're done, you can hit play again. So for number 1, let's take a look. So find companies located in all cities. So the first half will have the company name and city, right? So whatever appears before all or every is companies, and whatever appears after is city. So the one on the left-hand side should have the name of the company as well as the city. Okay, C name and city from company, okay, in which it's located in small bank corporation. So whatever is on the right-hand side should be returning the cities of the companies where the company name is small bank corporation. Okay, so we did company. So we did company. You could have done company display C name and city. So this implies that you are displaying company and city. Okay, and then here we have city. Okay, these are all the cities where the small bank corporation is located. Okay, so this will return all the companies that are located in every city that the small bank corporation is located. Number 2, find the average salary. So we know that we're going to be using an aggregate function of all employees for each company. So for each. So whenever you see the keyword each, that we're going to be grouping by company. Okay, so company is C name. So we're grouping by company. So for each company, we have an aggregate function. The name of the function is called average. We're taking the average of the salary for each company from the works table. Here, last one is find the name of all employees who earn more than every employee of small bank corporation. Assume that all people work for at most one company, okay, and make sure you use the aggregate function. Okay, so go ahead and pause it, and you should be taking about 4 to 5 minutes per query. Okay, so let's take a look at how we can do this. Okay, so here we are using works, okay, and then we want to look at the company name being small bank corporation, but we're looking at every employee that works at small bank corporation. Okay, and we are using an aggregate function, and we're looking at who earns the most, right? Or more than. So this will return the maximum salary, whoever makes the most, who work at small bank corporation. So this will return a single value, which is called, we're going to rename it to be max salary. So T alone, this will just return a single value. So it'll have a column up here that has max salary, and it's going to return one just single row of data. It's going to be some number, some max salary. Okay, so we're taking that T, taking a Cartesian product between that and works. Okay, so salary is from works. So the salary of this person who's working, it doesn't really matter where they're working. And if they are making more than max salary is the maximum salary from whoever works in this bank, right? Yeah, so if they make more than whoever makes the most from small bank corporation, that means that they're making more than every employee in small bank corporation, right? Okay, so then we want to return the name of this employee. So that's why we have this. Okay. So this might seem a little bit difficult, a little bit confusing, but as you do more practice, it'll get easier. Okay, so this was the last lecture on relational algebra, and then next lecture we're going to start on SQL.